Now in this example, we again have a survey and we want to check whether pet preference and gender are somehow linked. That, for example, females prefer cats, males prefer dogs, or the other way around. So that is our question. And we have here our little survey. And what we are required to do is we need to calculate the marginal sums of the table. We need to create a table with expected results, and from that calculate a chi-square value, and then make a decision whether there is a gender preference. So the first part is fairly straightforward. We just simply need to calculate the marginal sums, and we can do that by just simply adding up the numbers in their cells. So we can write equals sum, and Excel has that predefined. So we just add up these two numbers here. 52, we get the same thing by dragging that down here. So 69, 29 and 40 gives 69. We could have done that in the head, but since Excel has it already pre-made, why not make life easy for us? And we do that for the columns as well. And calculate this one here, and also calculate the grand total. So that 121 is our grand total. So these are the marginal sums and the grand total. And now we need to calculate how many people we would actually expect. And here there is a very simple trick of doing that, because what we want to do is in the expected table, so that is this table here, in the expected table, we want to find out what is the expected number. And to do that, all we need to do is take the marginal sums for the respective cell. So here we have this one here, and divide it by the grand total. So in this case, we would have equals this number so equals our number, our 52 here. So equals 52 times 48 divided by 121 gives us 20.6. For this cell here where the female hate cats, we do the same thing. So we do 69 times 48 equals 69 times 48 divided by the grand total gives us 27.37. Now for the males, what we do here is we take 52 multiplied by 73. 52 times 73 divided by the grand total. And also this cell here, so that would be 69 times 73 divided by 121 gives us 41.6. So these would be the expected numbers. We can again check whether they are in line with the numbers from the marginal sums. So we can say equals sum, and we'll just simply add them up here. So we get 52, 69 and we do the same here. Do the calculation for this one, for the columns. This is actually just to simply check whether we made any mistakes or whether everything is good. And what we see is that the marginal sums from the observed and the marginal sums from the expected data absolutely are in agreement. So we did not make any silly mistakes here, and that's quite reassuring. Now, of course, we have here fractional numbers, decimal numbers, and of course we can't have 20.6 females. We can't chop them in bits, but for the sake of the calculation, we just simply can accept that as it is. What we now need to do is we need to calculate the chi-square numbers, and just as a revision of chi-square, chi-square is defined as the sum of the individual observation minus the expected number to the power of 2, so squared, divided by expected number. And what we can very easily do is now we can just simply compare our numbers here and do this calculation. So we have equals, we take 19 minus the number in here. That is our expected number, squared divided by the expected number, and that would give us our individual chi-square. And instead of having to type that in all the time, we just simply use the fill-in function from Excel, and we can also go to that side here and fill it in. So I always want to make sure that we have done it the right way. So this would be, no, I don't think we've done it the right way. We've done 19. Okay, sorry. We need to do it step by step. So this would be here 29. I made a silly error here, and this number here we need to take 33, and for this number here we need to take 40. So now we have our chi-square numbers here, and all we need to do now finally is we need to sum up the data. So we just take the sum of the 4 data here, like this, and we get our chi-square value of so that is our chi-square value, 0.37. Now, what does that mean? We also know that the critical value is 3.84. So what does that mean? Now, let's think about it. We have our chi-square distribution here. So here we have the probability, here we have the chi-square numbers, and chi-square distribution looks like that. It's not symmetrical. We know that the critical value of 3.8 is the limit for the data where we have 95% of our data located in. So that's basically our confidence interval. If there is no link to gender or link between gender and cat preference, we would have a confidence interval from 0 to 3.84. This is where we would expect 95% of our data to be located in. Now, we just calculated a chi-square value of 0.37, so that might be just somewhere here, so that would be 0.37 in this case. And we see that our calculated chi-square value is very nicely within this 95% confidence interval. I probably should call this 95% confidence interval here. And this means that we can be very sure that there is no link between gender and cat preference. So I hope this makes sense, and thank you for watching.